With the arrival of Nuke 13.1, we made several improvements to Nuke Air tools. Aside from significant processing speed improvements, we added features that allow customers to run third-party models natively inside Nuke. This means you can start using PyTorch models from the wild, empowering you with the full capabilities of machine learning in your pipeline for faster iteration. Let me start by showing you a Nuke pipeline that we set up that uses one of these third-party models in the inference node. For your own experiments with the updated toolset, you can acquire useful models from GitLab and ModelZoo, for example. Here we have an input image that is getting passed to the inference node. The model of the inference node applied to the input image is a third-party semantic segmentation model. What this model does is segment particular objects in the input image. We set up a contact sheet here where we can see the input to the inference node on the left, the output to the inference node is in the middle, and then on the right we have the output with the alpha channel merged over the input image. And by clicking into the inference node, we can see that it has drop-down menu with several options that let you select what object you would like to segment in the input image. So we can select and segment sky, cars, trees, road, walls, signs, or people. Note that this semantic segmentation model is just an example model that we chose for this demo, but there are many other models that you can choose from that perform a wide range of edits. In this video, we are going to introduce a new node called CatFileCreator. This node will enable you to create CAT files from a third-party model so you can use it in the inference node. We will also show you how you can create a custom knob such as this one, which allows you to control parameters defined in the forward function of your model, giving you the ability to control the output of the model at inference time. Let's start by taking a look at our new node, the CatFileCreator. This node is what we will be using when creating a new CAT file. Before using the node, we will need a PyTorch model in the torch script format. For instructions how to perform this conversion, please follow the documentation supplied by the PyTorch group, which you can find on the link below. For the purpose of this video, we have already converted the chosen model to the expected torch group format, so we will simply point the knob to where the torch group file lives. Next, we have to add the location where we are going to save our new CAT file. Then, we can add the input and output channels that the model is expecting. Next, we can add the model ID, which allows the user to encode the model name into the CAT file. Here, we define the output scale expected by the model. This value indicates how much larger in scale is the output image resolution to the input image resolution. In this case, our input and output image resolutions are the same, so the scale value is 1. We also like to add a drop-down menu with options that will control what objects in the input image will be segmented during inputs. To do that, we will be dragging and dropping a user knob here. The drop-down enumeration menu is just one of the user knobs that you can add to your CAT file. Take a look at our documentation for a full list of user knobs that are supported in the CatFileCreator. Now, when we are converting this model from PyTorch to torch script, we use enumeration values in the forward function to control which objects will be segmented in the input image during inference. The custom enumeration knob that we are creating here is going to be linked to the enumeration value we used in the forward function of my torch script model. For instructions on how to write your own torch script model with the values that can be controlled by custom knobs, please follow the documentation provided on our help page to create a custom enumeration knob. First, enable username editing and drag a pull-down choice knob into the CatFileCreator, opening the knob settings. There, our 4 options will be filled in. The most important one is the name. This is the name of the variable used in the model's code function in PyTorch to control the output of the model. When converting this model to torch script, we call this enumeration variable chosen class. The second option is a label. We've called it an object. The menu itself are values that will appear in the drop-down menu, and finally we can add a tooltip exiting this menu and disable username editing. We can see our enumeration knob has been created with the defined label and drop-down options. Once we are set with these parameters and defined all our custom knobs, we can press Create CAT file and Inference. This will automatically create the inference node with the newly created CAT file inside. We can also see the input and output channels are listed, and the enumeration knob is created here in the inference node as expected. Now, if we add the inference node to our image pipeline, you can see that the output image changes as expected. When we change the drop-down value in the enumeration knob, the image recomputes and outputs the new alpha matte. Note that this particular model assumes that images would be in sRGB space at input time. So in our read node, we read the image as raw data format to ensure pixels are not converted from sRGB to linear color space. Thanks for watching, and we hope you enjoy using these new features of Nuke's Air tools.